The FCDIST module calculates the fault current distribution in multiple terminals, transmission lines, and distribution feeders using minimal information and a simple set of data concerning the network. The current division factor, or split factor, described in the IEEE 80 standard, the current distribution along shield wires, neutral wires, cable shields, and similar metallic paths, as well as the tower potentials, are important quantities that can easily be determined by FCDIST to alleviate unnecessarily conservative requirements on a grounding grid design and for an accurate safety analysis of substations. This is a simplified circuit diagram of a power transmission system. The location where a fault happens, whether that be a tower or a substation, is chosen as a central site of the FCDIST model. Other substations that are the sources of the fault currents are considered as terminals of the model. There are typically multiple terminals in a system, and with FCDIST you can model as many as are required for a realistic simulation. Now let's use the software to create a project and specify the central site, the terminals, and the energizations. When you installed FCDIST, an SCS software folder was created on your desktop. Double-click on this folder and then double-click on the FCDIST icon to launch the program. In the working directory field, you can enter or browse to the location where your work will be saved. In the current job ID field, enter the job ID of your file. In the list of modules, click on the FCDIST icon, and upon selecting a specify session, the FCDIST main screen will appear. First, set up your case by selecting the appropriate system of units, either metric or imperial. By clicking on the Edit Comments button, you will also be able to type a description of the study for future reference. Then begin specifying the system. Input the average soil characteristics and the working frequency. The name of the central site can be customized, but most importantly, its grid impedance must be defined. Now we can start defining the electric network by adding the terminals to the central site. Click on the Add Terminal button. In the dialog box that appears, specify the terminal name and select a terminal type among the 6 preset choices. For this tutorial, we will select an overhead transmission line with 1 shield wire. In this screen, you will specify the characteristics and location of the shield wire conductor. The values for the characteristics can be specified directly in the user interface, or alternatively can be imported from the conductor database, SCS library, provided that you know the type of conductor. Additionally, the transmission line average span length and its total length up to the terminal substation must be specified, together with the grounding impedances of the towers. You must also specify the location of the faulted phase wire and the current flowing through it. Here, you can also specify the terminal impedance and the connection status of the shield wire to the terminal grounding system. When you click on OK, you will see that Terminal 1 has been specified, and no error or missing data have been reported. Now we will define Terminal 2. Often the configuration of other terminals is quite similar. In such cases, we can use the Copy Terminal feature to speed up data entry. You can click on the Edit Terminal button to change any dissimilar aspect, for example, the length of this terminal. If additional terminals are required, you can likewise begin specifying these by clicking on the Add Terminal or Copy Terminal buttons. When all the terminals have been specified, click the Save Session button to save the project. Then click the Process button to run the case. When the run is finished, you may close the run window and then click on the View Plots and Reports button. SCS Results Viewer is the recommended output session to be used to examine computation results from FCDIST. When you click on the Report button, a summary report is generated in the Results Display panel, and here you can find the current split factor at the end of this report. Other important quantities summarized in this report include total earth current at the central site and the return current from the central site to each terminal via the shield wire. Various quantities can be plotted, such as the shunt potentials, which is the potential of the towers, as well as shunt currents and the current flowing in the shield wire. The results can be plotted per terminal, or you can include any two terminals in one plot. You can load a file similar to the one presented in this tutorial by using the Browse to Examples button in the FCDIST main help ribbon. Navigate to the Tools subfolder, where you will find the FCS FCDIST folder. This folder contains the file fc_3 terminals with single shield wire .f05, which can be used as a reference for this tutorial. This concludes our introductory video tutorial for FCDIST. Should you need more help, be aware that a help manual for the application is available and will open to the proper page by pressing the F1 key while the cursor is in any given field. Several how-to manuals also discuss the use of this application. And don't forget, you can also find on our website a knowledge base populated with frequently asked questions, a list of technical publications written by SCS employees, contact information for our support services, as well as training options. We hope you enjoyed the video. Thank you for being a valued SCS client, and thank you for watching.